Suppose we have a bag containing 4 red and 6 green marbles. 2 marbles are drawn randomly and they are not replaced before the next selection is made. Let X be the number of red marbles selected. Determine the probability distribution for the discrete random variable X. So the first thing we can do is we can set up a tree diagram to represent the selections made. So on the first selection we can select a red, or we can select a green marble. On the second selection, we can select a red or a green, and the same for the bottom of the tree, we can select a red or a green. So the probability associated with each of these selections is determined based on the number of marbles over the total number of marbles present. So if there's 4 red and 6 green, there is a 4 in 10 chance of getting a red the first time, and a 6 in 10 chance of getting a green the first time. Once we've selected one marble, we now have 9 remaining because we haven't replaced it. So getting a red marble the second time, we've got 1 red marble selected, leaving 3 out of 9. And there's still all 6 green marbles out of 9 remaining. If we selected green the first time, all 4 red marbles are still there out of 9. And if we selected a green marble, we've now only got 5 green marbles out of the 9 remaining. So we calculate the probability of each of the outcomes by multiplying along the branches of the tree as each event is independent. So the probability that we have red is equal to 4 over 10 times 3 over 9. And when we do that multiplication, we get 12 over 90, which can simplify down to 2 on 15. Then the probability that we have red then green is equal to 4 over 10 times 6 over 9, which equals 24 over 90, which equals 4 on 15. Then we have the probability that we get green followed by a red is going to equal 6 over 10 multiplied by 4 over 9. And when we do that, we get 24 over 90, which simplifies down to 4 on 15. Finally, we consider the final 2 branches, which is the probability of getting a green followed by a green, and that is equal to 6 out of 10 times 5 out of 9, which equals 30 over 90, and if we simplify that down, that's equal to 5 on 15, or even 1 in 3. So to finish part A, we can set up a table which holds the information of the discrete random variable's probability distribution. So here we can have the values of X that our distribution can take, and then below it we're going to have the probability that the random variable is equal to that value. So we can have 0 red marbles, we can have 1 red marble, or we can have 2 red marbles being selected. So the probability that we have 0 red marbles selected is the probability of green followed by green, which is going to be 5 over 15. So I'll leave that as a common denominator, so these are easier to add and subtract in a minute. And then the probability we get 1 red marble is the same as saying the probability we get a red and a green, added on the probability we get a green then a red, which is 4 over 15 plus 4 over 15, which is 8 over 15. And finally, the probability that we get 2 red marbles is 2 over 15. For part B, it says, find the probability that 1 or more red marbles is selected. So this is asking for the probability that X is greater than or equal to 1, which is the probability that X equals 1 plus the probability that X equals 2. And if we have a look at the table, the probability that X equals 1 is 8 on 15. And the probability that X equals 2 is 2 on 15, which is equal to 10 on 15. And simplifying that, there is a 2 in 3 chance that we draw at least one red marble from the bag.